Hello and welcome to my YouTube channel, this is Manual Life Mathematics. Today we are going to do with mechanics, and let's look at the definition of a mechanic. So we said that mechanics deals bodies, okay? So the mechanics deal with effect that force have on what bodies. So we are going to talk about force or the effect of force on bodies. That's all about mechanics. Now let's look at branches of mechanics. So here we are going to look at the three main branches of mechanics. So we have these are the three branches of mechanics: the mechanics of rigid bodies, mechanics of deformable bodies, mechanics of what fluid. Now let's look at the mechanics of what rigid bodies, mechanics of rigid bodies. Then, in fact, you will be taking them one after the other, but our focus will be on the mechanics of rigid bodies. So let's look at what the types or what forms under the mechanics of what rigid bodies. So for the mechanics of rigid bodies, you are going to have static and dynamic. So these are the two that fall under the mechanics of what rigid bodies. Then we also have mechanics of deformable bodies. So for that one, we have mechanics of deformable bodies, theory of elasticity, theory of plasticity, theory of failure. And when we come to mechanics of rigid bodies, you have the static and what? The static bodies, then dynamics bodies. Then let's look at the mechanics of fluid. Mechanics of fluid. Okay, so these are the three types or the two under this. Mechanics of rigid bodies is static dynamic. Mechanics of deformable bodies is theory of elasticity, theory of plasticity, theory of failure. Then that of mechanics of fluid, that compressible and what incompressible. So these are the three main types. Now you are going to look at the meaning of the static and what dynamic. That one you will not go much into it, but let's look at what that one means. So when you say static bodies, static, what does it mean? So now when we say that static body, it's just talking about when a body acts on a balanced force. We say that that body is in a static form, okay? So, and these bodies, or when bodies are in the balanced forces, then you can say that they are their equilibrium state. You can say they are their equilibrium states. So they are in equilibrium state. So the body is said to be in equilibrium state when all the forces acting on that body is what? Balanced. So what are some of the bodies that are in equilibrium state? We can have typical example of this as a body at rest. So when we have a block, let's say this is a block. This block is there, okay? This block is at rest. You may think that it's just lying there, just like that. No, there are forces acting on that block, and that force are all balanced. So let's say a force is acting here, a force is acting here, a force is acting there. So let's say if here is 50 Newton, here too is 50 Newton, here too is 50 Newton, 50 Newton. So these are the things that you should know. All the forces acting on that body is balanced. Then you can say that that force or that body is in what? Equilibrium state. Then we also look at dynamics. the dynamics. Now, let's look at the dynamics. For the dynamics, also in twofold, okay? But the dynamics talks about, okay, let me look at the twofold. For the dynamic, can have the kinetic and kinematics. So these are the two types of dynamics that we are going to look at. We have the kinetics and kinematics, okay? So if you look at these two, the the kinetics and the kinematics, these two, what do you mean by kinetic and what do you mean by kinematics? When you say kinetic, the kinetics deals with the motions and the force acting on the body. So the kinetics, okay, I'm using the kinematics and the kinetics at the same time. The kinetics is interested in the motion of the body and the force acting on it. Is that okay? So this is interested in what? The motion and what? The force acting on the body. But when it comes to the kinematics, that one, it ignores the forces and deals with what? The motion. So for the kinematics, it ignore the forces. It's not, the kinematic side is not interested in the forces, but rather interested only the motions on that body. So these are the two main things that you should know about the kinematics and that, or sorry, the kinetics and that of what? The kinematics. So we are going to deal with especially the kinematics. That's where most of the work will be on. You treat the kinetics later. Is that okay? So now let's look at the different topic. Okay, so now you are going to look at the definition of distance, speed, time versus displacement and what? Velocity. But velocity, displacement, and time also. But the definition of time here will be the definition of time there. That's why I'm just bringing one time. Okay. Now, first, let's look at what a distance is. We are saying that the distance is a position of a point in relation to another point. Okay. So let's say this, or let me give you the definition. You say a distance is what? A position of a point in relation to another point. Full stop. Okay. So here, what we are saying here is that let's say I have point A and I have point B. This is a distance AB. Is that okay? We have not talked about direction. The distance is only focusing on the position of one point to another point. That is it. Is that okay? Now let's move on to the displacement. Displacement. Now, when we talk about displacement, displacement is a distance in a particular what? Direction. So displacement is a distance in a particular direction. Full stop. Now you realize that for a displacement there's a direction, but distance there's no direction. So example is, if I stand at point A, then I will be moving to, let's say, point B. Okay, but this A is moving to B, so there is a direction. You see that there is arrow. Or when you are moving from point A and you are moving to the north direction. So for displacement, there is a direction. Distance, we just look at the difference between 2 points. Okay, good. Now let's look at the formulas that bind this parameters together. So let's take the distance, for instance. So we have distance equals, now distance is always given as speed times time. Is that okay? So distance is always given as speed times time. So it means that if I want speed, then that will be distance over what? Time. In fact, speed is a scalar quantity. Distance is a scalar quantity because there is no direction. Time. So everything here is what a scalar quantity. Speed and distance, they are all scalar quantity. Then let's also look at displacement. So displacement is equal to the velocity times time. Okay, so in this case, if I want to make velocity the subject, my velocity is equal to displacement over time. Therefore, velocity is a vector quantity because displacement has a direction. So displacement too is a vector quantity. Okay, so now let's look at this example. Find the displacement of a body from a fixed point O in 3 minutes. If the body is moving with a constant velocity of 15 kilometers per hour, find also the time taken by this body to travel 200 meters from the fixed point at the velocity. Is that okay? So here, let's see how we can do this question. We know that displacement, which is always abbreviated as S, okay, is given as velocity times what? Time. We said that displacement is equals to velocity times time. Is that okay? Now in the question, time has been given as what? 3 minutes. And also, velocity has been given as 15 kilometers per second. So time is equals to 3 minutes. Velocity is equals 15 kilometers per hour, right? 15 kilometers per hour. So what we are going to do is that because here is kilometers per hour, this is minutes. So we convert this minutes to what? An hour. So if you want to convert minutes to an hour, is every 1 hour will give us 60 minutes. So it means that 3 minutes will give us 180, sorry, will give us 3 over what? 60 here. So which gives us 3 minutes will give us 1 over 20 hours. Is that okay? So I've converted the 3 minutes to hours. So when that thing happens, it means that our displacement will be equal to velocity, which is 15 multiplied by 1 over 20. So my S will be equal to 5 going to 20 3 times, goes here 4 times. So that will give us kilometers. Is that okay? You can also multiply this 3 over 4 by 1,000 to get in meters. Is that okay? Good. Now let's look at the other side. Find also the time taken by this body to travel 200 meters from the fixed point at the velocity. Is that okay? So now we want to use the same velocity which was given to us as 15 kilometers per hour with the displacement or the distance given to 200 meters. Is that okay? So here we want time. We know that displacement is equals to time times velocity. So if I want to make time the side, time will be equals to S over what? V. But before I will do the substitution, we know that our V is 15 kilometers per hour. So let's convert these 200 meters given to us. So we have the distance given us 200 meters. Is that okay? So these 200 meters, if I'm to convert it to kilometers, because the velocity given, the velocity is in 15 kilometers per hour. So I have to convert the 200 meters to kilometers. So we know that every 1 kilometer will give us 1,000 kilometers. So if I'm converting this to kilometers, I simply divide the 200 by 1,000. So 200 meters will be 200 over 1,000 kilometers. Is that okay? So 200 meters will give us, this will cancel this will cancel this. 2 will go into 10, 5, right? So that will be 1 over 5 kilometers. So now our time is going to give us S, which is 15 over, sorry, the S is a 1 over 5. So this will be 1 over 5 divided by velocity, which is 15. So my time, remember the time will be in hours. So here will be 1 over 5 times 15. So this will give 1 over 75 hours. Is that okay? 1 over 75 hours. So that is the time that is used. In hours, you can change it to what? Seconds or minutes, depending the unit you want to change it to. Is that okay? Let's look at a different example.